Have you ever wondered how solar panels turn sunlight into electricity? Welcome to the world of solar power, a realm where the sun's radiant energy is harnessed to power our everyday lives. From powering homes to charging electric cars, solar energy is increasingly becoming an integral part of our world. At its core, solar power is all about converting sunlight into usable electricity. Intriguing, isn't it? Let's delve deeper into this fascinating process. To comprehend this transformation, we first need to understand what a solar panel is. A solar panel, often seen on rooftops or in large open fields, is a device designed to absorb the sun's rays and convert them into electricity or heat. The main components of a solar panel are the photovoltaic cells, commonly known as solar cells. These are small, square-shaped semiconductors made from silicon and other conductive materials, layered together. Each solar panel is comprised of many of these cells linked together, and it's these cells that are the key to converting sunlight into electricity. Picture a sandwich. The top layer of the cell is loaded with electrons, while the bottom layer has room for additional electrons. When sunlight hits the top layer, it excites the electrons, causing them to leap to the bottom layer. This movement creates an electrical current, so essentially, these photovoltaic cells are creating electricity by playing a microscopic game of leapfrog with electrons. Now you might be wondering, how do we get from this tiny electrical current to powering our homes and gadgets? Well, this is where the other components of the solar panel come into play. The electric current created by the photovoltaic cells is collected by metal conductive plates and sent to an inverter, which transforms this direct current into an alternating current that can be used in our homes. So, the photovoltaic cells in solar panels play the star role in this energy conversion. But how exactly does this happen? Stay tuned to find out more. The magic happens within the photovoltaic cells, but what makes them so special? Photovoltaic cells, or solar cells as they're more commonly known, are the beating heart of a solar panel. They are the tiny engines that convert sunlight into electricity. But what exactly are they made of? The primary ingredient is a magical element called silicon, the second most abundant element on Earth, found in everything from sand to computer chips. Silicon is a semiconductor, which means it's a material that can both conduct and insulate electricity. This is crucial for the functioning of photovoltaic cells. But silicon alone isn't enough. It's usually mixed with other elements like phosphorus and boron to create a structure known as a silicon sandwich. Now, the top layer of this sandwich, laced with phosphorus, has excess electrons, while the bottom layer, infused with boron, has room for more. This difference creates an electric field between the two layers. When sunlight, or more specifically particles of light called photons, hit the photovoltaic cell, they energize the electrons. The electric field then pushes these energized electrons out of the silicon sandwich, creating a flow of electricity. The more intense the sunlight, the greater the flow of electricity. This process, known as the photovoltaic effect, was first discovered in the 19th century, but it wasn't until the mid-20th century that scientists were able to harness it efficiently. Today, photovoltaic cells are found everywhere, from rooftops to space stations, silently converting sunlight into usable electricity. But here's the most magical part. Every second, our sun releases enough energy to power human civilization for nearly 2 million years. And with photovoltaic cells, we can tap into this vast reservoir of power. It's like having a tiny piece of the sun right here on Earth. So we now know that these cells absorb sunlight, but how do they turn it into something we can use? This is where it gets exciting, the conversion of sunlight into electricity. Let's break it down, shall we? Imagine the sun's rays beaming down onto a solar panel. The sunlight, comprised of tiny packets of energy known as photons, interacts with the solar panel. More specifically, it's the photovoltaic cells within the panel that the photons get cozy with. Now, these cells are made of two layers of semiconducting material, usually silicon. When the photons hit these layers, they excite the electrons, causing them to break free from their atoms. It's like a dance party where the photons are the music and the electrons are the dancers, breaking free and moving to the beat. But it's not just a wild dance party, it's a carefully orchestrated ballet. The cells are designed in a way that these free electrons are pushed in a particular direction, creating a flow. This flow of electrons is what we call an electric current, but we're not quite finished yet. The electricity generated by the solar panel is direct current, or DC. This is where another crucial component comes into play, the inverter. The inverter's job is to convert this DC electricity into alternating current, or AC. Why is this important, you ask? Well, most of our homes and devices use AC power. So to make the electricity generated by the solar panels usable, it needs to be converted into AC. The inverter does just that, like a translator converting the language of the solar panels into one that our homes understand. It's quite a journey, isn't it? From the heart of the sun, through space, to our solar panels, and finally into our homes. Every step is a marvel of science and engineering, harnessing the power of the sun and converting it into something that powers our daily lives. And voila! The sunlight is now ready to power your homes and devices. So, to sum it up, the journey of solar energy conversion is a fascinating blend of science and nature. It starts with the sun, the ultimate source of energy, emitting light that reaches our planet. This light is then captured by solar panels, which are strategically positioned to soak up as much sunlight as they possibly can. Within these panels are photovoltaic cells, the real magicians in this process. These cells are composed of semiconductors, usually silicon, that absorb the sunlight. When the sunlight hits these cells, it excites the electrons, creating a flow of electricity. This electricity, however, is in direct current form. Using an inverter, this direct current is converted into alternating current, which is the type of electricity that powers our homes and devices. And voila! What once was mere sunlight is now a powerful source of electricity. And that's how solar panels harness the power of the sun to keep our lights on. Isn't it amazing how we can utilize sunlight, a natural and abundant resource, to generate electricity? It's a testament to human ingenuity and the incredible potential of renewable energy. Solar power isn't just a concept in a science fiction novel. It's here, it's now, and it's lighting up our world in the most sustainable way possible. Imagine a future where every rooftop harnesses the power of the sun, where energy is clean, abundant, and virtually free. That future can be ours if we choose to embrace solar power and other renewable energy options. So why not dive a little deeper? Why not explore more about the magic of photovoltaic cells or the intricacies of solar energy conversion? The knowledge is out there, waiting for you to discover. The more we understand, the better we can advocate for a brighter, cleaner, and more sustainable future. Don't forget to like, share, and subscribe to our channel for more interesting insights. Thank you for watching and stay curious.